Hello, students. Today we're going to look at a very influential package. It's called Table 1. It's by Kazuki Yoshida. I've included the initial documentation inside the learning portal in the modules. The Table 1 package eases the construction of the Table 1, the patient baseline characteristics commonly found in biomedical research papers. The packages can summarize both continuous and categorical variables mixed within one table. You can use categorical variables summarized as counts and percentages, and continuous variables summarized as mean and standard deviation, or as mean and interquartile ranges. Okay, and now the other thing that you can use this package for is propensity scoring. So that's the other use of this package. I want to mention that up front, but we'll start with just creating a basic table 1. Now, the nice thing is this is what's called an R vignette. So there's directly copy and pastable R code available in here. So we'll start by loading our table 1, loading our library and table 1 packages. And then the data is an inbuilt data set called PBC. So we can look at our inbuilt data set. We just run that line. So we have ID, time, status, treatment, ascites. So we have time to event data by ID. So if we use the create table 1 function with data equal to PBC, we can quickly see an overall summary of the 415 patients in the data set with a mean and standard deviation, and the categorical variables have been auto-detected here, for example. However, the way to do it when you want to actually convert categorical variables, you can use this dput names. The other thing you can use is dput all names, PBC. And what that does is it gives you a concatenated list of the variables, how it actually appears. So what that helps you do is it helps you to create a list of variables. So we're going to call this my vars. We're going to use all lowercase, not like in the example here. And the authors here have selected from these variables, their categorical variables, we'll call it cat vars. So for example, we'll just take the authors list here, but you can select them yourself, which variables you want to be categorical in your data set. And then now we're using this create table 1 variables equals my vars. We made it lowercase, factor vars equals cat vars, and data equals PDC. So now when we make tab 2, oops, I didn't run my vars. Okay, my vars, cod vars. Now when we run it, we can see the cat vars are broken out by level. Okay, so status, for example, edema, everything in our list of cat vars is broken out by level and percentages, whereas the other variables are mean and standard deviation. So now, okay, okay. Now, what else can we do with this package? We can also show all levels for each categorical variable. So we can use the show all levels command for the print. Now, you can use also summary tab 2. Okay. So let me show you now how to. Okay, so this is how to format non-normal variables. So we can select biomarkers, for example. and we can select, we can say non-normal equals biomarkers. That's the option. And now when we oh, I didn't run biomarkers. When we run the line, you can see it's now summarized by median and IQR. So anything you want to summarize by median and IQR, you can put using a non-normal argument just simply on the column names from the deep put. Really nice and easy to use. Okay, so let's leave it there for this lecture. Try and generate this table one with your own with the PBC data set, and try it with the NFL injuries data set or your own data set, and just try and run it yourself.